Welcome back to this beautiful channel. If you are joining us for the first time, please kindly subscribe to our channel. Click on the notification bell so that you'll be the first to be informed when our videos are coming. In this channel, we have been saying that we don't just give you the answer, say A is the answer. We tell you why A is the answer. In the process, we explain other options to you. So we have been solving past questions on physics. We're going to continue from where we stopped, and other subjects are coming. Chemistry and biology will be coming very soon. Please kindly stay with us as we enjoy your support. Thank you. Question number 8. A bulb of weight 0.1 Newton hangs from a massless ring of length 50 centimeters. A variable horizontal force which increases from 0 is applied to pull the bulb until the strings make an angle of 60 degrees with the vertical. The work done is A says 0.25 joules, B says 0.025 joules, C says 0.05 joules, and D says 0.5 joules. Now from this question we're asked to calculate the work done. So I'm going to write the work done, which is the unknown, and then from the question we're given that there is a force of 0.1 Newton, and then the length is 50 centimeters, and it was moved through an angle of 60 degrees. So I call this angle theta. And we already know that work done is the product of force and distance. And from here we have length. So we can represent distance in different forms. Length is distance, height is distance, distance is height, distance is length. So we have different ways in which distance can appear. So in this case, our length is going to serve as the distance. Because this length is measured in centimeters, we have to convert it to meters. So the length is 50 centimeters divided by 100. Now if we divide 50 by 100, we're going to have 0.5 meters. So simply the work done here is the product of the force. The force is 0.1 Newton times the distance 0.5 meters. So 0.1 times 0.5 gives us approximately 0.05 joules. So the total work done here is 0.05 joules, which makes option C the final answer. I hope that answers the question. Question number 15. Question number 15 states, one special advantage of alcohol over mercury as a thermometric liquid is its A, low freezing point, B, low boiling point, C, high specific heat capacity, D, low density. As we know, a thermometer is a device that is used to measure the degree of hotness or coldness of an object or of a body. And we know both alcohol and mercury are good thermometric substances, and each one has an advantage over the other in some aspects. So we have, basically, we can have a thermometer made from alcohol. They normally call it alcohol in glass thermometer, and we have thermometers made from mercury, which are mercury in glass thermometer. So according to the options given to us here now, the only point in which the alcohol has an advantage over mercury as a thermometric liquid is D, which is the low density. Alcohol has a very low density compared to mercury. I'm going to show you the picture of alcohol that is used in making thermometer and then the mercury, so that you can compare and contrast their densities. I hope that answers the question. Now question number 16. Two metals P and Q of lengths L1 and L2 are heated through the same temperature difference. If the ratio of the linear expansivity of P to Q is 2:3 and the ratio of the length of their lengths is 3:4, what is the ratio of the increase in length of P and Q? Now this question is on linear expansivity. We have three types of expansivity. We have linear expansivity, we have area expansivity, and then we have spherical expansivity or cubic expansivity. Now we normally denote the linear expansivity using alpha. Now from this question, we're told that we have two variables here. We have P and Q, and this question is basically making reference to their ratios. Now, the linear expansivity of P to Q in this question was given in a ratio. Now, the ratio of P to Q, their expansivities, they said P is 2 and Q is 3. So, the ratios of their linear expansivity is 2:3. And then the ratio of their lengths, P to Q, let's take L to be length. The ratio of their length, P to Q, is P is 3 and then Q is 4. And now we're asked to look for the ratio of the increase in length. We know that the change in length in linear expansivity L2 minus L1 for P and then all over L2 minus L1 for Q is equal to the alpha L1 theta for P and then divided by the alpha L1 theta for Q. Now when we look at this, we know that the expansivity ratio of P to Q is 2:3 and their length ratio is 3:4. And we already know that for us to calculate the change in length for P is L2 minus L1 for P into alpha L1 theta, and then for Q is L2 minus L1, which is the change in the length, is equal to the linear expansivity of Q times the length and then times the change in temperature. Now from the question, we are told that the temperature is constant between them, meaning the ratios of the temperature are cancelled. So the whole of this is equal to the alpha for P is 2 times the linear expansivity, the length for P is 3 divided by the alpha for Q is 3 times the length for Q is 4. So we'll have this, we can compete for the ratios. So L2 minus L1 for P all over L2 minus L1 for Q is going to give us 2 divide itself 1, 2 divided by 4 is 2, and we're going to have 3 all over 3 times 2, we're going to have 6. When we further divide this, we're going to get 1 over 2. So when we have this, the ratio is 1:2. Now what have we done here? Because the entire question is simply on ratios, so we're going to write out the formula for change of length of P, that is the new length of P all over the new length of Q, and then we're going to substitute the values given to us in this formula. The alpha of P is 2, alpha for Q is 3, that is 2, 3, and then the length for P is 3 and the length of Q is 4, and since the temperatures were not changing, they were the same, all we need to do is to cancel them out, and we'll multiply this and we'll divide through, we're going to get 1/2. So 1 is the ratio of P and 2 is the ratio of Q. This is how their length varies. I hope that answers the question. Now from this, we can find out that option C is the final answer. Now question number 17. The density of a certain oil on frying becomes 0.4 kilograms per meters cube with a volume of 20 meters cube. What will be its initial volume when its initial density is 0.8 kilograms, assuming no loss of oil due to spillage? Option A says 10 meters cube, option B says 5 meters cube, option C says 8 meters cube, and option D says 12 meters cube. Now from these questions, they are asking, we have initial density and we have the final density. Now the question started by saying the density of a certain oil on frying becomes. Now this is a new density, which we are going to call D2. It becomes 0.4 kilograms per meters cube. And D2 is now the new density. This is what it became, and it became this density at this volume V2. The volume when it became this was 20 meters cube. And now we're asked to look for the initial volume. The initial volume, which we are going to call V1, which is unknown, and they said the density at this initial volume, which we are going to call D1, is 0.8 kilograms per meters cube. Now since we have our data out, and we know that density is defined as mass all over volume, the ratio of mass to the volume. Now if we look at the mass was not given in the question, it means the mass was constant throughout. So all I'm going to do, I'm going to calculate for the mass. This implies that the mass is going to be density times the volume. Now which density and which volume? The final density and the final volume. Now the mass is equal to, the density here is 0.4 kilograms per meters cube multiplied by the volume, which is 20 meters cube. And if we multiply this by this, we are going to get 8 kilogram. Now the mass that is constant to all is 8 kilograms. Now since we have gotten the mass, we cannot get the initial volume using the initial density. Now the initial density D1 is equal to the initial volume V1, sorry, the mass M all over the initial volume V1. Now if we substitute the data into this, the initial density is 0.8 kilograms per meters cube, which is equal to the mass now which we have gotten to be 8 kilograms divided by the initial volume. So if we make the initial volume the subject of the formula here, V1, we are going to have 8 kilograms divided by 0.8 kilograms per meters cube. And when we divide this, 8 divided by 0.8, the initial volume is going to be 10 meters. Meters cube. So now the initial volume is going to be 10 meters cube. I hope that answers the question. And now this leaves us with option A as the final answer. Now question number 18. Question number 18 states, heat is radiated by all hot objects in the form of A, light energy, B, solar energy, C, infrared rays, D, X-rays. Now, any substance that is capable of bringing out heat, there is a form in which these heats are radiated. And from the option here, these heats are mostly radiated as infrared rays because solar energy is the main source is from the sun, and then the light energy is also an energy that is gotten from the sun also and other luminous objects, and then X-rays is an electromagnetic ray which comes out including infrared rays. But now the best option here is the infrared rays, which is option C, because every hot object radiates heat in form of infrared rays. So option C is the answer. I hope that answers the question. Now question number 19. Question number 19 states, if a container is filled with ice to the brim, what happens to the level of water when the ice is completely melts? A, the water in the bottle, the water in the glass outflows. B, the level of water drops. C, the level of water remains unchanged. D, the level of water goes up. Now, what is this question trying to tell us? Now, they're saying, what do we mean by filling it up to the brim? Now, I get a glass cup and I fill it up with ice. So what will happen when the ice melts in the cup? That's just what they're asking. And then A says the water in the glass will outflows, that when you fill a glass cup with ice, that when the ice melts, that is going to overflow and the water will start throwing away. B says the level of the water drops, that after the ice melts, the level is going to drop. And C says the level of water remains unchanged, that is going to remain constant. And D says the level of water goes up. So whenever you fill an ice in a cup, when you come back, the level of the water is going to drop compared to the ice. So which makes option B the right answers. The level of water drops. You can practicalize it at home, get a cup, fill it up with ice, note the volume where it stops, come back after some time, when it is melted, you see that it has dropped a little bit. I hope that answers the question. Question number 20. The small droplets of water that forms on the grass in the early hours of the morning is A, dew, B, mist, C, fog, D, hail. Now from the images we've given to you, see that there is a little similarity between mist and fog. The only difference is that fog is denser than mist. And from the pictures above, you will know that the final answer to that question is A, dew. I hope that answers the question. Now question number 21. A vapor is said to be saturated when A, a dynamic equilibrium exists such that more molecules return to the liquid than are leaving it. B, the vapor pressure is atmospheric. C, the temperature of the vapor varies. D, a dynamic equilibrium exists between liquids, molecules, and the vapor molecules. Now, I'm going to draw a container here, and this container is going to contain liquids in it. I have liquids inside this container. Let's assume it is heated and vapors are coming out from this container. Now the question is telling us that when is this vapor saturated? Now there must be an equilibrium, a dynamic type, such that it is happening continuously. So when there is a dynamic equilibrium between the vapor and the liquid, the quantity of the vapors falling in is equal to the quantity of the liquid turning into the vapor. Now when this cycle is at equilibrium, we said that the vapor is saturated. I don't know if we're getting it right. So if the amount of vapor falling in and the amount of liquid turning into vapor are in a dynamic equilibrium, we said that the vapor is saturated. So if we go back to the option again, we're going to say that A says a dynamic equilibrium exists such that molecules return to the liquid and are leaving it. B says the vapor pressure is atmospheric. C says the temperature of the vapor varies. And D says a dynamic equilibrium exists between liquids, molecules, and the vapor molecules. So from what we have explained so far, you're going to say that option D is the final answer. I hope that answered the questions. Question number 22. The pressure of 1 mole of an ideal gas of volume 10 raised to the power minus 2 meters cubed at a temperature of 27 degrees is now if we look at this question, it is actually talking about the ideal gas law. Are we getting now? We're going to put down the details and we're going to put it on the formula so that we'll follow. Now it says the pressure of 1 mole. We are basically looking for the pressure, and the number of moles is given to us to be 1. I said the pressure of 1 mole of an ideal gas of volume, and the volume is given to us to be 10 raised to the power of minus 2 meters cubed at a temperature, and the temperature given to us here is the temperature is 27 degrees Celsius. And we know when we're solving questions like this, the temperature is always converted into Kelvin by adding 273. So when I add 273 here, I'm going to have 300 Kelvin. Now, the formula for calculating ideal gas is PV equals nRT. And from this question, we're told that the rate constant R is 8.3. So my rate constant R is 8.3 8.3 joules per mole per Kelvin. Now we have our rate constant here. So now we're going to substitute this into the formula. We're asked to look for pressure. So all I need to do is to divide both sides by volume. So my pressure now is equal to nRT all over V. So now it is now looking very easy. All we need to do is to just substitute the values in. So the pressure P is equal to the number of moles given to us is 1 times the rate constant is 8.3 times the temperature is now 300 in Kelvin divided by the volume, and the volume is 10 to the power of negative 2. And when we multiply the above and we divide it by what is given us below, the pressure is going to be 2.49 times 10 to the power of 5 Newton per meters squared. Now this is the pressure. So from this we can see that the option C is the right answer to this question. I hope that answers the question. Thank you. Now question number 23. Which of the following has no effect on radiation? A says density, B temperature, C surface area, D nature of the surface. Now what we need to understand first is that these radiations are not matter, so they don't have particles. So temperature is going to have an effect on them. Surface area, because they normally penetrate, is going to have an effect on them, and the nature of the surface also is going to have an effect on these radiations. So the only parameter here that cannot have effect on them is density. Moreover, these radiations actually don't have densities on their own. So option A is now the right answer to this question. Question number 24. The wavelength of a wave traveling with a velocity of 420 meters per second is 42 meters. What is its period? A 1.0 seconds, B 0.1 seconds, C 0.5 seconds, D 1.2 seconds. Now we're going to bring out the data and then we'll solve for the period. Now we were asked to calculate the period, and the period is denoted by T, which is unknown. And from the question, the velocity is given to us to be 420 meters per second, and then the wavelength, which is lambda, is given to us to be 42 meters. And then we're asked to calculate the period. Now the period T is equal to 1 over the frequency. But the frequency is not given to us in the question, so we need to search for it. Remember the wave formula where V is equal to F lambda, where F here is the frequency, V is the speed, and then lambda is the wavelength. So we're going to make F the subject of formula. This implies that F is equal to V all over lambda. So my F now is going to be V 420 meters per second divided by 42 meters. I'm going to have approximately 10 hertz. So now the frequency here is 10 hertz. But we're asked to calculate the period. The period, which is T, is equal to 1 over the frequency. And the frequency we have gotten is 10. So 1 over 10 will give us 0.1 seconds. So if we look at the option, we're going to find out that 0.1 seconds is actually option B, making it the final answer. I hope that answers the question. Question number 25. The sound of an electric bell dies down slowly when air is slowly pumped out from a bottle because A, sound cannot pass through the bottle, B, sound can pass through a vacuum, C, sound needs a material medium, D, the wavelength of sound becomes greater in the bottle. Now sound wave is an example of a wave we call mechanical waves, and those mechanical waves are waves that require material medium for them to propagate. Now the fact that you are hearing me as I'm speaking to you right now is because there is air. So air is a medium that is transmitting this sound that I'm making and is taking it to your ears that you're listening to it right now. So without air, the sound will not be there. So now, if you go back to this question, you're going to find out that they are saying that the sound of an electric bell dies down in a bottle when air is slowly pumped out from it. And if you look at option C, says that sounds needs a material medium, which is the air. Because the air is going out of the bottle, the sound is going to fade away. When you bring the air back into the bottle, the sound is going to be back alive. I hope that answers the question. Question number 26. During a thunderstorm, the sound is heard over a long time. This phenomenon is referred to as A, refraction of sound, B, reverberation, C, superposition, D, diffraction of sound. Now, refraction has to do with separate mediums, whereby sound travels from one medium to another and the direction of propagation is changing as this sound is moving from one medium to another, like the movement of sound from air into water and others. And we know that diffraction simply means when waves bend around obstacles. And the right answer for the reason why the sound waves have a longer period of time lasting is simply reverberation. Reverberation is like echo. Are you getting it now? So option B now is the right answer to this question. I hope that answers the question. Question number 28. In comparing the camera and the human eye, the film of the camera functions as the A, iris, B, pupil, C, cornea, D, retina. Now, the films of the camera are simply where the images are stored. And this functions exactly as the retina in the human eye. The retina is simply where these images are formed. So now, like the camera, the human eye uses retina, while the camera uses the film. So this makes option D the final answer. I hope that answers the question. Now, question number 30. An object is embedded in a block of ice 10 cm below the plane surface. If the refractive index of the ice is 1.50, the apparent depth of the object below the surface is... Now, this question has to do with a refractive index. A refractive index is represented by this Greek symbol. Let me make it bigger. This is refractive index, and refractive index is real depth all over apparent depth. Now, from the data given to us in this question, the real depth of this thing, an object is embedded in a block of ice 10 centimeters below the plane surface. And the real depth here is 10 centimeters. And the refractive index is given to us to be 1.5 and 1.5. So we're asked to calculate the apparent depth, which is unknown. So the refractive index is real depth all over apparent depth. We have the real depth. If we make the apparent depth the subject of formula, the apparent depth is equal to the real depth all over the refractive index. So we just substitute the value into it. The real depth is 10 centimeters and then the refractive index is 1.5. So when we divide 10 centimeters by 1.5, we're going to get approximately 6.77 centimeters. So the apparent depth of the block of ice is 6.77 centimeters, which makes option A the final answer. I hope that answers the question. Thank you for staying with us. We have come to the end of this chapter, which we've solved up to 30 questions. If you're coming in for the first time, please kindly subscribe to our channel, click on the notification bell so that you'll be the first to be informed when we're releasing these videos. So our next video is going to contain the remaining part of the physics question of 2010. We really appreciate your effort. Thank you.